Good evening again. This is Suraj Singh speaking from Bharat, India regarding clay, Montmorillonite. This is a file and this number to file and microstructural analysis and magnetic characterization of native and magnetically modified Montmorillonite and vermiculite. This is the title of this paper. This is a screen share which I am going to attach with one of my videos that is regarding clay soil microstructural analysis and magnetic characterization of native magnetically modified Montmorillonite एंड वर्कवाइज वही चिकनी मिट्टी के बारे में दूसरी फाइल जो मैं डिस्कस करूँगा वीडियो के अंदर ये उसका पेज दिस इज हैविंग 25 पेजेस दिस इज टाइटल ऑफ दैट वन आई एम गोइंग टू स्टार्ट दिस वन फॉर यू पीपल एंड आप देखते हैं दिस इज टाइटल हियर एंड दिस इज व्हाट इट इज and I have to say means how can I do this and this is where your message how to do that that's so simple here let me see how to attach this one this is an important one yes and this is you can say I am now browsing it इसकी details हैं well I'm not interested in that this published in 2018 and this is the structure of this is very important here if it's structure of this now this is regarding structure of basic structure unit of polysilicates now physiosilicates is phyllosilicates are part of you kind of you can say this is that if you understand this figure 1 very well you may see this आपको दिख रही है आराम से इसमें कोविड के बारे में लिखा हुआ गलत चीज़ों से कन्फ्यूजन नहीं कीजिए अलग है बात दूसरी है उसकी now this structure is if you go this अब ध्यान से देखिए स्ट्रक्चर को basic structural unit basic structural unit this is basic structural unit of phyllosilicate an integral part forms sheets of octahedrons X bracket oxygen hydroxide 6 which shares not only vertices but also half of see vertices here है ये आपका triangle देखेंगे आप this is a triangle here this is another triangle here this is like double triangles here and then continuation of this another double triangle and then this is another triangle here and there's a small triangle here this is axis of that because this is there so another triangle continuation of another one this is basic unit here this is basic unit here the continuation of this continuation this is it is you can say this figure is showing you this triangle integral part form an integral part forms sheet of octahedron which shares not only vertices but also half of edges this vertices here होते हैं this vertex this is vertex this and edges you see this is half of these edges this is here this internally if you see this is 8-sided figure 1 2 3 4 5 6 like that so but also half of edges octahedron are tacked together by octahedron planes perpendicularly to 001 these are octahedron planes perpendicular to 001 and this is so that 3 anions O minus and OH minus form a lower layer 3 anions are in upper layer and in between octahedral cations. This is chemistry like atomic structure of that. It's in different form it's giving. Octahedral gas X mostly aluminum, ferric and magnesium are present. And the occupation of structural position in octahedral sheet generates tetrahedral sheet silicates where each OH is surrounded by 3 divalent cations like Fe2 or I move forward and you go there you will find now this is different chemistry of this is a Montmorillonite layers essentially clay minerals can be modified in two ways in interlayer spaces in persons of selling and cation exchange and in surface due to adsorption process अब देखिए इसमें if you see in pink color गुलाबी रंग ये जो आपको दिख रहा है गुलाबी pink color इस एल्यूमिनियम और ये दूसरा जो रंग है और हल्का सा दूसरा सा that is your Fe iron and ferric and H unit here white so H unit in that So, this is the same triangles that you saw here, different units of triangles and in the connection of that. Mg magnesium here, green one, if you see, green one, this is magnesium here, can you see here? Ox is O is there, also, all the red, and silica is yellow in person. This is silica here. So, these are 6 chemicals here. This is aluminum, pink color here, Fe is a little gray here, H is a white color here, magnesium is green color here, oxygen red and so on. This unit and this is the same unit here. You are just also blowing it, you can see the same one. A and B is given, this is A and this is B. Let us see that if you can see something here. You can see that one, you can see that one here, you can see that the same, A and B, it is here, and it is same if you see this upper one. This is your upper one. You see then of here same colors of you can see colors very clearly now. This pink, this color is here, this aluminum, and this is other one. This is here is Fe iron, and Fe iron is here like this, and other side is also same, and H is this is H unit here, and this is magnesium here green, and then yellow silica here. This silica yellow, this silica yellow, this is oxygen, and this is oxide, this is magnesium here, and H is here, this is so yeah, all same units you have seen that. You go further here, you will find different continuation of this. You will see this continuation here, selected continuation here. Same one is continuing J and up and the same is here, 1 and 2, 1 and B, A and B is shown here. So I'll come down to back to that position. A and B are here, and we can see this here, of course, and here down this original level. So this is here, we can see previous one was here, that is here, and now this expansion I have shown is a phenomenon to be higher. This is that, and now it is further. But now we are committed with an excellent group of absorbents. Montmorillonite and vermiculite are used as effective solvents for removing toxic ions, toxic molecules from wastewater. पानी में से जब जहरीले मॉलिक्यूल्स निकालने होते हैं वेस्ट वाटर से, जब भी आपका जाता है वेस्ट वाटर, उसके भी काम आएगा, उसको छानने में हो सकता है. In last years, new materials are designed to improve sorption efficiency, decrease the price of purification. This is purification technology, and enhance the functionality of material. In order to improve sorption properties of clay, million different acid activation and other chemical procedure modifications were developed. Most of papers are devoted to improvements of clay minerals from viewpoint of their applications. Clay minerals modified by metal oxides of their interlayer species are known as pillared clays. Oxide particles act as pillars and keep silicate layers apart and form two-dimensional molecules of cells. Compared to original clay minerals, they have a higher fraction of surface area. बहुत बढ़ जाता है. सरफेस एरिया बताएंगे आपको. आप 1 ग्राम से आपको 1 ग्राम अगर ले लेंगे कोई भी मिट्टी, उसको जितनी जगह फैला सकते हैं बारीक मिट्टी को, उतना सर्विस एरिया होता है. एक मॉलिक्यूल भी नहीं बचना चाहिए. In present study, main attention is devoted to analysis of complex structural and magnetic properties of magnetically modified montmorillonite and vermiculite using iron oxide particles and original unmodified clay minerals. Structural properties, morphology, and chemical composition are determined by X-ray fluorescence spectroscopy, scanning electron microscopy (SEM), transmission electron microscopy, and X-ray diffraction. Macro and micromagnetic characterization of samples are achieved by magnetic and measurements at room and elevated temperatures completed by low thermal measurements. और ये आपके देखिए आगे चलते हैं. Different types of minerals for use in present studies: montmorillonite and vermiculite. Montmorillonite consists of double aluminum and magnesium silicates was obtained from A, from A, that is there. See, from A, this is a complete same. Let's say here you can say Yeah. X-ray was performed using an energy dispersion X-ray tube. So use the transmission electron microscopy, transmission electron microscopy TEM, GL 2010 SC रेजोल्यूशन। ये सब टेस्टिंग का है, ये बताने के लिए, पढ़ने के लिए। और उसके बाद एक्सरे पाउडर डिफ्रैक्शन एंड Mosser spectrometry. Then we go to formula. Now zero field cooled ZFC and field cooled SP curves were measured between 2000 and 300,000. Magnetic field of 8 kA per meter. Thermomagnetic curves representing magnetic behavior of samples, etc. Results and discussion. Chemical composition and methodology. Result of chemical analysis of original MIT and magnetically modified MTT samples using XRFS and EDF are summarized in table. An increase in content of iron oxide after magnetic modification is evident at both samples. Besides Fe2O3, a small amount of Besides Fe1X was detected. A total content of iron oxide 8.38% was slightly higher in vermiculite. तो ये आप देखिए। इसके बाद इसमें दूसरी चीज़ें भी हैं, मैं वो नहीं दिखा रहा हूँ, फिर खाली सीधी बात कर रहे हैं अपने से। एंड ये आप चलेंगे आगे तो देखिए टेबल दिए यहाँ पे। This is there. If I expand this, you can see the outline. Here 5 is there. Then SME micrograph of sample empty with marked large area A, and this morphology A, and point B EDX analysis. And then it's about minerals are highly sensitive. Continuation from here you see the more detailed morphology of vermiculite and montmorillonite sample in their original empty and modified MV states are seen in TEM micrographs. They document that submicron iron oxide nanoparticles occur at surface and integrate etc. And this is another detailing of the same one, and there's a curve here, and that is both curves are here showing these results. This is red differentiation intensity counts. This is x1 and this is 2 theta degree, and you see vermiculite and montmorillonite is 40 to 100, and red differentials you can see what's happening here. Now Mosser spectrometry, this is another one. Same curves are here, the graphics are here. This is all how to do it chemically, how to know this analysis. This is actually iron will present both minerals Fe2 and Fe3 tetrahedral nocturnal environment. They can be distinguished by hyperfine parameters. So same thing is there, which we will understand this in regular video. This is all for information that it's moving up. And this is magnetization here, and this is magnetic field here, both are here. So magnetization AM square kilogram, and this is magnetic field here, and these are different curves of same one, A, B and C, and table for room temperature, RTS at low temperature. This magnetic parameter is original MTVR, and interparticle magnetic interactions for analyzed by Henkel. Okay, this is such work, and this is curve figures. So this is another curve here. This is TMC curve in figure 10b are visibly different due to magnetic modification affecting changes by Fe-based compounds, curing temperature, Curie temperature, all that, MB or MT. So then low temperature magnetic properties are magnetically modified. LT looks so simple both originally and so we go further in this conclusion. Now conclusion is very important for us to understand what it says actually. To see conclusion says Montmorillonite from From smectite group, there's a group of clay, smectite group and vermiculite from vermiculite group were magnetically modified by mixing original clay minerals with iron oxide particles prepared using a microwave irradiation procedure. Complex structural magnetic studies of original magnetically modified powders were performed using scanning and transmission, electron microscopy, X-ray fluorescence, spectroscopy, X-ray diffraction, misobor spectrometry, and magnetic methods at room temperature. Most of the results supported also by low temperature measurements. Both clay minerals of 2:1 layer type and SCM observations yield similar morphology and large area as local dot chemical homogeneity of all studied samples. Nevertheless, the micrographs clearly show large particle agglomerates at vermiculite sample, contrary to Montmorillonite consisting of very small separate nanoparticles. Original clay minerals behave in a way corresponding to their composition. Vermiculite with higher content of iron-based compounds yields slightly softer magnetic properties and presence of magnetic components at very low temperature, while Montmorillonite is paramagnetic and superparamagnetic at both room and low temperature. Magnetite modification changes magnetic properties of both samples in different ways. Particle agglomerates in vermiculite cause magnetic hardening and prevailing dipolar interaction or dipolar coupling, which refers to direct magnetostatic interaction between two magnetic dipoles moments. Contrary, magnetic modified montmorillonite exhibit supermagnetic behavior at RT with nearly zero coercive field and magnetization. Remnant magnetization. It measures temperature fluctuations of nanoparticles easily overcome barrier consisting of their anisotropic energy. Marked increase at C at 2000 confirms that during cooling, magnetic nanoparticles attract properties typical for magnetically ordered material and pass into a blocking state at TB corresponds to 150,000. Data availability, experimental data used to support findings of the study are included within this article. And these are references, various references the author has taken, and these I'm just trying to show you that there are so many papers and all that. There is nothing to do with this talk. Yes, I'm taking that. I'm just moving back onto that just to show you, because I had to finish. Means I had to finish this share, screen share now. These are all technical issues, very much complicated, and but for those who can understand this, those engineers, it's for them. This is a reference file, reference video with this URL of this will be placed in that video section so that people can refer to it if they want to refer to. It's up to them. I can't force someone, but this is for knowledge sake. This is for regarding clay, and there are so many X-rays in this. Many methods are there to understand what is that. And this is the only reason that I tried to show to you this. And here is what results and discussions, etc. And various methods here. Various methods of that. As I said this, I told you all explanations, experimental sample vessels given there. So this is the real structure. This is real structure of this, and this is a very important part of that. And this is this one. Phyllosilicates, basic structures. Microstructural analysis, and magnetic characterization of native and magnetically modified Montmorillonite and vermiculite. This is that one. So I'll stop this now. Thank you very much for this indirect talk of Montmorillonite's microstructure analysis and magnetic characterization to be associated to attached to routine video. This is for screen sharing. Thank you very much, channel.